Hello, well done. Welcome to Code or Not to Code. I'm Millie Eva, and I'm super happy to be here today. And I'm here with Stefan. How are you doing?
I'm seeing that the streaming tool is lost connection to Twitch. I'm not
No!
just 2 seconds before you went live. That's embarrassing.
Wow, what
Uh,
a start. Apocalypse now. No, it's amazing. Wow, that's never happened. We've been streaming for how many years now? 2, 3?
3 almost, I suppose.
Three
Yeah.
almost. And this is a first, even for us. So this is one of the themes that I guess we have on this stream. So you never stop learning. And yeah.
Oh no, actually.
Are we
Oh
live?
no.
Are we still? What
No,
happened?
not on Twitch, only on YouTube, because this channel is currently unavailable due to a violation of Twitch's community guidelines or terms of services.
What happened?
I don't know. I suppose I got an email. We'll check this later. So today it seems to be YouTube only. We did bad.
We did that. What? What are you saying? We didn't even on Twitch or on
Somehow,
where?
yeah. I guess we got flagged somehow.
We didn't
I do not know.
even do our bathtub episode yet. So like.
It's actually interesting. But I'm gonna trace this later.
Yeah. Okay, fair enough. Well, hello YouTube.
So much for
How
welcome.
are you doing? Amazing. Well, yes, if you're new to the show, hello Eric. Nice to see you. Well, Eric's not new, but if you're new, the two of us do meet every other week and code together. Learn together and apparently break rules together. So yeah, and actually today we've got a really cool continuation of our previous episode, because we're bringing together two of Stefan's absolute favorite subjects, which is benchmarking and source generators. So yeah, it's a really big deep dive. I'm obviously usually in over my head, but that's why we've got Stefan the expert, and obviously you beautiful people to help us out and yeah, make this happen. But before we get into the content, we do have a little trivia section prepared for you. Well, yeah, we have a topic prepared and we're going to dive into it, I guess, together a little bit.
Yes, I'm just reading through there's Twitch.
Well, no, I want to know.
No,
Is
but
it
yeah, I'm trying to only view the relevant comments, not the Twitch ones. This one, yes. It appears that our NDC Oslo talk isn't doing too bad in Oslo 2025 playlist.
That's amazing. I love that. It was so much fun. Like, if you don't know, Stefan and I went to NDC also earlier this year, and it was my first conference ever, and I was so nervous. Like, yeah, I guess Stefan also saw a completely different side of me that day. I don't think you've ever seen me this nervous. But yeah, it was a really, really wonderful experience, not just being on the stage and giving the talk, but just the entire conference was amazing. So if you've never been, I highly recommend it. I do hope to be back again, because yeah, it was really cool, and I learned a lot. I actually thought maybe this will be fun, but I actually also learned a lot. So if you're a company, do send your employees there. It does make a lot of sense for everyone.
Cool. I'm sharing the video also in copy link, the YouTube chat only today.
Exactly. So please watch it, because we want to be top 3.
On YouTube, not on Twitch, apparently. Yeah. Oh,
well,
yes. It seems that Twitch has discarded us.
Wow! What a perfect bridge to our trivia.
Thank you, Twitch, for providing us with this amazing segue. Let's do some top-level statements. Yeah, let's talk about the discard and the discard pattern. So I guess if we had a type, let's call it, it's publicly available. class, the flash or where class, or the where we can't have a type name starting with a 2. So yeah, so I'm using the flash over class. And let's say this one has a public bool start stream result. And well, if Twitch or whatever currently, so this will be the Twitch implementation, it will just return false. So let's create an instance for flash over type, and we could now start the stream.
Well,
but what if I don't care about the result? Because, well, I know they discarded us. It's a done deal. So maybe I really don't want to care about the result. I mean, I could just ignore the return type Boolean. I just don't write it. But for example, you as a reviewer, you wouldn't know, hey, are you ignoring it consciously or have you just forgot about it? And to communicate that, I could use the assign it to this discard variable. Well, that's not really available, so this is just an underscore. And this is, in this case, it's not an identifier. I couldn't, for example, now print this to the console because it will say does not exist in the current context. If there is no type to it, well, the thing is, underscore actually is a valid identifier. I could, for example, have a class, because I think this feature was introduced in C# 7 or something. So this has not been there originally. If it was, I can imagine the rules would be different in C#. But I could have a class that starts with underscore. I could have a class name that is just underscore, because underscore is a valid identifier. So if I just have the underscore, it's the discard. But I could also give it the type, like just liking like a variable, like I would have bool result. But I just call this local field, this local variable, I just call underscore. And now this is a valid identifier because I also use the type name. So in general, it's a valid identifier, but if you omit the type name, then it's a discard, and then it's not an identifier. And it basically then is the same result as if we weren't, if we were ignoring, if we compile this to C#. Well, we see stream is started, but there is the return type is just discarded, but we can't just be explicit about it in source code. I guess it's also similar about stuff that is ignored by the compiler. Underscores in numbers. So we could, since I don't know which C# version, we can also have underscores in numeric, what's the name? Constants? Literals. There we go. For example, we could just have a 1000. We can't have an underscore. We can't have a leading underscore. We can't have a trailing underscore, but we can have underscores in between and how many we want. And what do you think this number now represent?
Still 1000, I suppose.
Let's compile, and indeed, it's still just 1000. Compiler's just ignoring the underscores. Well, it helps if I format my stuff like a 1000 separator. Let's say I want to do 1000 now. Here I see immediately, okay, that's 100,000. Without that, yeah, I first need to check, okay, is this 1,000, a million? A bit difficult. And but I could also kind of make it weird and do the separator like there. Now it looks like 10,000, but yeah, it isn't. It's still 100,000. So.
Yeah, you can kind of play around with that a little bit. And I think last episode we did almost run into like like we had a bit of a, I guess, a misunderstanding, because I guess it was with the dot and it was not exactly the same, but because of the formatting, we thought we were looking at a very different number than we were actually looking at. Do you remember? When we were summing up the
Oh, yes, there was, I think.
Yeah, so it does seem a little bit trivial maybe now, but it makes but it makes a big difference, I guess. Or it can be very misleading, especially when you're tired.
Oh yes. Laszlo is writing the 16 or missed the OB. I think, yeah, for binary numbers. I think you can also have, is it for binary? I think you have a 0. I think for hexadecimal, you can do 0x underscore, and then you have a hexadecimal number. For example, F0, I think, is 240, in hexadecimal. So if we do 0x underscore F40, if we run this, we should get 240.
There it goes.
There's also a binary prefix. You can do 0b, I think, and then enter a binary number, 0010, 0001. I'm absolutely uncertain what I wrote. Something like, I don't know, 36? No, let's find out. 33. Okay.
Oh, wow. Close.
And yeah, so this is also, in these cases, you actually do need the underscore to have this, basically if you don't have any prefix, then it's just, what's that? The decimal number. You can make binaries, and with 0b and 0x, you can have hexadecimal numbers.
Awesome.
And what else? Yeah, there is much more that we can discard. Let's say we create a dictionary where there's integer as key and this string as a value. Create a new instance, or let's use collection initializers, of course. And let's say we can try to, for example, this example, we can try to add a number. Let's add 1 and 1. And if we were to add 1 with 2, now this will fail because the key 1 already exists, and add is really just trying to add it. If it exists already, it will throw. And we will get an argument exception. Key already exists. If we were doing a try-add, then the first one would win. So in the first, it would try to enter it. And if it doesn't exist, enter it. If it does exist, do not overwrite it. So in this case, we would then, if we would then do a console.writeLine dictionary at index 1, we would get the 1, not the 2. So if I kind of want to make something, hey, ensure that this key exists, then, and again, try-add returns in a Boolean whether this operation was successful or not, where the first one will return true because it added it, and the second one will return false because it already existed. And again, we can discard it. We can also use this with, talking about collection initializer and the list pattern. Let's say we have a list. A list of integers. And
if you're interested in learning more about the list pattern. Oh no, are we doing the list pattern? We didn't do we?
Well, we talked about it.
We
implemented it in our session. So yes.
Perfect. So if you're interested to learn more, check out our NDC video.
Where we could say if our collection is, with a discard, we can say any item. And this would be single. So if our collection only contains a single item. So if we do contain a single item, but it doesn't matter which number it is, this would be true. If we have more, 2, then this will not print anything because it's not a single item. We could also say, well, underscore, which is now saying any 2 items. Well, we could also say, the first number must be a 1, but the second number, anything really. And again, this would match. And this is now first is 1, second any, and we would indeed get that output. We can also combine it with the range pattern, ... which is now at least a length of 2, because where the first element is 1, the last element is any, and in between any amount of numbers. So this would still, if we run this, any in between, this would match. And if we add now any amount of numbers in between,
you forgot.
If I was doing my numbers right, it would still match because the first one is a 1, the last one is any, so we have at least a length of 2, but all the other items are just anything. Can you do double underscores and that would not be a discard anymore?
Good question.
I believe, maybe let's bring the dictionary back. I think would then be, actually not sure. I would expect this to be invalid then. because underscore is not an identifier. Yeah, it doesn't exist in the current context. So I would need to kind of provide a Boolean bool underscore. And yeah, now I give it a name. Okay, so only a single underscore can be a discard if it doesn't exist in the current context. If it exists in the current context, now this underscore is actually, now we are assigning this to that Boolean, and we can actually print this underscore. It's a valid identifier, and we would get, well, this one set it to true, this one sets it to false, so we should get false, yeah, at the end. And one last thing about the discard, well, that's not really a discard. Well, is it? Well, it's quite kind of a discard, but it's more like an ignore thing. Same with the list pattern matching. We could, maybe let's do a key value pair of int string. Let's create that, how do we call this? KBP. Let's create a KBP with 1 and the string 1. And we can also do pattern matching on that. Or we can also switch over it. We could say, we want to get some result value, maybe, what do we want? A string result. And we can switch, no, wait, it's switch, I'm always writing this wrong. First the variable, then the switch expression over it. And we can also do some pattern matching there. And no, it crashes.
Woo! Oh, we had that today already, right?
If we, let's copy that code. No, I can't copy the code.
No! Don't leave.
Page isn't responding.
Oh.
Yes, we see that.
Wait, we'll wait.
Can we load it again?
Funny, we used to be on SharpLab, now we're on here, yeah. But I don't know.
Okay.
Okay, good.
No, but it's still the old state. Have we tried turning it off and on again? Oh, no. Oh, okay.
Wow.
There is no perfect tool. Okay, let's go again.
Maybe we could find one. No.
Ooh. Well, will it be better than the... I don't know. Well, maybe. KVP equals to key value pair dot create 1 and 1. And we want to have a string result where we switch over the KVP and say, okay, if we can do some tuple pattern matching there because a key value pair is deconstructible.
Aha.
Where we could,
and if you're interested to learn about the deconstruct pattern, check out our NDC video on YouTube.
That's also here. Yeah, we covered a lot of it in there, actually. I just realized. Where were we? There we are. Okay. Before we come to the switch, let's discount, because we can deconstruct, let's say, key and value and assign KVP to it.
Mm-hmm.
Oh, I can't type. And, oh, I need a bar, yes. And maybe let's see that working with a good old console.writeLine. And we can individually print the key and the value. We have decomposed them, deconstructed them into separate variables, 1 and 1. But let's say we only care about the key. What if I don't want to use the value? Again, we can discard it.
Mm-hmm.
And what if I don't care about either? Then we can discard both. I mean, yeah,
then we can't.
They are not identifiers; they don't work. But then this operation is kind of useless. But yeah, we could discard both.
What does the compile? What happens with this line 13? Is this just going to get?
This may get totally
dismissed.
Vanish. Oh no! It actually still deconstructs it into variables, but we just don't speak of them.
Okay.
I can imagine that the
That's
JIT
funny.
compiler, then may totally remove it.
Yeah, just should hope so, I guess.
Mm-hmm. And yeah, so and with a similar pattern, we can also use this in pattern matching. We could say if the first element, the key, is anything, again with the underscore, but the second one, the value is 1, then we return, I don't know, yay. If the first one again is any key, but the second one is also anything. That's kind of like the fallback. So if this one hasn't matched, if there is no first key, if the key, no, wait a minute, the value, if the value of this key value pair is not 1,
Yeah.
then use this result. Basically, this is what it's saying, and it says Twitch does not like us anymore. And in this case, well, we would now get the result. Would be now, in this case, we got the 1, we get the yay. Yay. And if we now have anything else, and also, or if the value would match, so to come back, if we use any key, since we said anyone, this would still match because the key can be anything, but the value must be 1. This would still match into yay. But if we now have basically anything else, now would go into the fallback, basically. And we can always, with a switch, we can also, that's the default case. If you have if you have a regular switch, like the switch that you write like a switch statement, like such, you then have your cases. And you can also always have the default case. And the default case will match if no other case matched before. And via a switch expression, you have the default case again with just an underscore. And this is basically unreachable. Well, the compiler understands it as well. Because we already have exhaustively matched it with this one, which is practically the default case. But if we didn't have this one, now, well, this is very reachable. That's basically the default case. So if nothing, we could say, okay, key is 1. This goes up, down order. So it first checks, is the key anything? And, well, is the value 1? Go to yay. Is the key 1? Don't mind about the value, also go to yay. But if anything else, now goes to default. And yeah, in this case, neither the key nor the value matches, so we go to default.
Okay.
And that's where we can use underscores. And Eric mentions common use case for Eric is when he doesn't care about the out var. Oh, let's bring the dictionary back. This one has an out. And actually, I think we actually come that's a nice segue then into our maybe you know what? let's use today we are in the segue mode.
Yes.
Since in our last episode we actually wrote we'll just come to what we built last time and then get more into the weeds of it. But we do use here we have an out. Well, we actually use the out afterwards, but here we do as well, but we don't really use the out diagnostics that we return.
Yeah.
We also see, this is kind of unused. Local variable is never used. Yeah, let's discard it. And, we still need the out. Yeah. Out. No, there we go. And again, now this underscore, this is not a valid identifier. It should say, it doesn't exist in the current context, cannot resolve the symbol. This is just discarded, this out parameter. Out argument.
Ooh.
This should be an out argument. Yeah, because the parameter is on the declaration side, but for the caller, it's a parameter. So this is then the out parameter.
Okay.
Well, actually, let's leave it like that. Speaking of, what
did we do last time? How far did we get?
Well, we haven't angered Twitch. Oh, this is I'm gonna play a lot on that, I suppose.
Yeah, me too. I mean, come on.
The only thing this really troubles me. The only thing I put in via Twitch was "Hello World," and then we got blocked.
How dare you?
Okay. Yeah. Well, totally lost my trail of thought.
What did we do?
Yes, I know that Twitch is angry. I'm getting notifications all the time that Twitch is angry.
Still? But we're not even there. But
yeah,
yeah.
no, but it's still, the tool is still
Okay.
trying to reconnect, but no.
Okay. I don't get
Tool thinks
notifications,
lost
so-
connection, but it doesn't know that Twitch banned us, basically, or suspended us. And
yeah, never mind. Maybe Hello World is now.
Hello World is
I
banned.
don't know. Is potentially banned. Somebody trademarked it or something.
Yes. So we wanted to build a benchmarking tool for generators. Well, for Roslyn tools in general, but starting with generators, with source generators, because there are some intricacies to it. It is not as straightforward as just with regular benchmarking. I have my method, and we would just put it in benchmark.net, write a benchmark, that then call my method there, and that's pretty much it, and all is good. Maybe add a memory diagnoser to also get the heap allocations for that method benchmarked.
Yep.
But yeah, that's pretty much it. That's quite straightforward. With source generators, it's not that straightforward, because if we take a peek at the implementation of a source generator, this is the same source generator that we built for our conference talk, where we auto-generate the deconstruct method, so that you can deconstruct any type. Well, you can actually deconstruct any type by following to a pattern. Then you can write this parentheses syntax that we showed earlier. And yeah, the input to the source generator, well, it's an I incremental generator that takes some incremental generator initialization context. Now, this is a public struct, but yeah, the constructor is quite internal. So we can't really, initialize that. We could use reflection to initialize it. But then, okay, what's an input? What's a syntax input node? I don't know the type. Another internal type. Incremental generator output node. Another internal interface. Syntax helper. Another internal interface. Well, I guess string, and bool. We could know what to do with there. But again, the rest is we wouldn't know how to create it. So we can't really go this path. We need to go the path that also tooling like Writer, Visual Studio, .NET uses in order to run the generator, and they use the oh, I made a wrong file.
Oh no.
Yeah, need to go to the benchmark. They use the generator driver. There's a C# generator driver, but also a Visual Basic generator driver. If I had we only have the code analysis C# package installed. If we would have also installed the Visual Basic package. Not doing this right now because we also have maybe let's follow that path. This doesn't work right away because we also have a directory.packages.props where we specify the version, because we see in our package drivers we don't specify a version, because we're doing this centrally with central package management, where we can go to. I'm missing a button here.
That's true.
There it is. I don't know why I was whispering.
It was a secret.
I don't want to anger YouTube as well.
Yeah, exactly.
We have our directory.packages.props, and in there we can now centrally specify the versions of the packages that we can then use wherever we want.
Yeah.
And let's add. We actually have. Let's format this. Yes.
Nice.
We also decided for tabs, Visual Basic package as well. And if we were to build now, this could.
Wow. Yeah. Okay.
Kind of just work. We need, of course, the Visual Studio namespace as well. The Visual Basic namespace as well, next to the C# namespace. But here's now the Visual Basic generator driver, because Roslyn is the compiler platform for both C# and Visual Basic. And you can do, well, from a compiler perspective, you can do, basically everything in both languages. There are some features, there were no language features that may only be supported on the respective language. But there is one compiler feature that I know of that is only supported in C#, which are interceptors. Interceptors don't work in Visual Basic. or not
Oh.
currently, or maybe
Mhm.
ever, but yeah. Okay, let's go back to our C#. Because, yeah, actually speaking of, I guess we could also then, because what we want to do is taking all these intricacies of benchmarking a source generator into a package that you could either copy the source code over or you use that package, and where we kind of then offer an API on some types that make you do the right thing with at least code possible. But first we need to find out what is the right way of running this source generator, because now we need the source generator driver. That's one component that we don't have under our control.
Yep.
And well, we can generate a generator driver by saying generator.create. And this takes a collection of incremental generators or also source generators. Those are the older version of generators. You shouldn't use these anymore, only them. But yeah, it still works. And we trail of thought. Where are you? Oh yeah, so we could also pass multiple generators. This is what a tool would do. If we say .NET build, they would take a peek at the project, find all of the generators. That's basically all of the types that are attributed with. This is why we have to attribute them. The generator attribute. Then it checks, is this generator also for the current version? Because if I have a C# project, but I have a VB generator, perhaps I shouldn't load this generator, or vice versa. But if I'm a C# project and I have a generator that supports C#, you can also have a generator that supports both. You could also say, as an additional language, I think additional languages could also say, I also support Visual Basic. If you support multiple languages. Yes. And so now finds these and then creates another generator driver. But there is more that the generator needs, because the generator is working on user code. How does this get in? Well, we found out that the generator, not only can a generator driver be created, but also a generator driver can run the generators and update the compilation. And as an input gets a compilation. In our case, we need a C# compilation. How do we create the C# compilation? Well, we give it a name. We also give it source trees. Well, the C# code is an input that we also need to create. So in our case, we only have a single document. We only have a single syntax tree that gets converted into a single document in this compilation. And then we can we also found out that we need reference assemblies. Because if we have a compilation that doesn't have anything else, it just has this syntax tree. But what about, for example, the BCL? Or if we have, I don't know, maybe a dependency to because I'm now building for my company a logging system, I'm now quite familiar with Microsoft.extensions.logging. Maybe this project also is dependency on that. Where do we get these assemblies from? They also need to be part of the compilation, where we are using a NuGet package that provides reference assemblies for the BCL. And in this case, we use the .NET 8 reference assemblies. We also found out the difference between implementation assemblies and reference assemblies. So the reference assemblies only contain the public API surface area that you can use when you write code and when you build code. But when you run code, the public API alone, without any implementation, doesn't do anything. For one time, we need the implementation assemblies that actually contain the code. Like the reference assemblies has a dictionary type and the try-add method and the try-get value method and all of that. But the actual implementation, how it works under the hood and the arrays it uses, then is in the implementation assemblies. So we need, but since we only built the code, Roslyn, it's build time, we don't run the code, reference assemblies are good enough for us. And we can also pass some compilation options. We saw when you have this, there's a lot of different compilation options. First and foremost, the output kind. So is this compilation a library or is this an executable? And so on. There's 5 or 6 different output kinds. We can also specify some. I think those are global usings. I'm not entirely certain if these are, or are there some aliases. We can also, this is how we, if you want to enable unsafe code in MS Build, you need to set the allow unsafe code, or allow unsafe MS Build property, which is then, we had in one episode, Martin Ulrich in our show, who showed us how MS Build works under the hood, which then extracts when MS Build is allow safe boolean and then basically passes it to the compiler via this option. And so warning level and so on. So there's a lot of stuff that we can configure via the compilation options. There's also parse options, but those are related to syntax trees, I think. So when we parse in here we parse the text, but we can also parse options. Those are for source code. So let's say we have our parse options, new C# parse options, where we could say the language version that this should be parsed with. Let's say we have C# 13 code. And we can pass this parse options here as well. If we were now downgrading to, let's say, C# 1, we would get during compilation an error because this syntax tree, well, it's parsed with C# 1. When you compile it, then yeah, in it, this feature wasn't known at C# 1 time. So this would then fail compilation. So there's a lot of options that we can set to create this compilation. And then eventually when we have those two parts, the compilation and the driver, we can then, run the benchmark. And we kind of found out that just because, well, we started with just this one benchmark, but the result was kind of fishy. And then we did the additional steps as well as benchmarks. So we just run the generate. So in benchmark.net, there is a global setup method, which runs before each benchmark. So let's say we have a global setup. We can also have a global, is it cleanup or teardown? I think it's cleanup. And let's say we have benchmark A and benchmark B. Those are the 4 methods with attributes that we have in our benchmark file. And what would happen? Well, first benchmark A would be run, but before benchmark A runs, we first get one execution of the global setup. Then we get many, many executions of benchmark A in order to not just run, because usually you do benchmark by running a method just once. That's giving not accurate results, and the JIT is also quite powerful. The more you run it, the more efficient it gets. What we learned 2 episodes ago. And
by the way, since YouTube is our new best friend, if you're interested in our previous episodes, head to our YouTube channel. You can see our episode with Martin Ulrich and lots of other guests, and and this one as well.
And get some steady state result, and then statistics are collected out of them. And then one time the global cleanup will be run. Then it's benchmark B's term, where we one time again run the global setup, then a lot of times the benchmark B calculate statistics and so on, and then a singular time the global cleanup. That's how it works. Well, in between, we could also have, I think it's iteration setup and iteration teardown, where the name suggests, I formatted this weirdly. Iteration teardown, no, also cleanup, same name, is which would be, so the global setups just still runs once. The iteration setups run as many times as the benchmark runs. So we first run the iteration setup, then the benchmark, and then the iteration cleanup. And this is then run in a loop. Iteration setup, benchmark, iteration cleanup, iteration setup, benchmark, iteration cleanup. A lot of times, but only the benchmark, only the statistics, and that just cleaned everything. only the statistics of benchmark A are considered. The iteration setup and the iteration teardown are not considered for the statistics.
Cleanup.
Cleanup, correct. Only only benchmark A has stats, and this is kind of the lifetime of benchmark.net. So
But
we were doing.
Yeah, we were doing the global setup. We weren't doing the iterative setup.
No, we haven't done that yet.
Okay.
And then we try to do all the steps individually and see if these numbers add up. We only create the driver. We only create the compilation.
Yep.
We do all of the things. We generate the driver, we create the compilation, and run the generator. We also have a version where we only create the compilation anew and the driver, but not we don't create the driver anew. Perhaps this is maybe also an option that we didn't consider last time, I think. So we could also have the version of, then we have all the permutations, creating the driver anew, but reusing the compilation. Well, this should be, or I think it's immutable. At least from a user's perspective, I'm the user of this compilation, it's immutable, but maybe it has internally some caching that has an influence on performance. Well, it definitely shouldn't have an influence on the output because Roslyn is all immutable or observably immutable, but internally they may do some caching as an optimization. I still observe the same result, but I could get it in a faster fashion, which would be driver and run, I think. Yeah. And basically what we try, we can discard here as well. Discard.
Yeah.
Woohoo. And also just run the benchmark. So we kind of have all the permutations. We just run the benchmark, we just create the compilation, just the driver and the combinations of it. And do these numbers add up? And
well, we expect some of them to add up. We don't expect the driver and run to add up, right? So this is kind of like
no, yes, all of them should add up.
But the others, they should also add up. But you just said
it kind of should make sense, right? It should be somewhat add up. Yeah.
Yeah. Okay. And some of them, yeah. Like,
for example, if we just have the run.
Yeah.
Well, the individual one. Well, I would assume that the individual one and the individual creates compilation and the individual driver is creating the driver. I named it weirdly. So these individual 3 steps should be somewhat similar to the combined version of it.
Yeah.
But it quite isn't, is it? Creating the driver is...
And this is where we actually got a little bit misled by the dots and commas last time. Because I think the first reaction was, maybe. And then it was like, no, not even close. Not even close.
Not even close. Because, here we are in the nanoseconds. It's like 500, what's that then? 400 nanoseconds, half a microsecond. But here we are at 4,000 nanoseconds, so that's 500 microseconds, so that's half a millisecond. Well, okay, one could argue we are sub-microseconds, or we are sub-milliseconds. Does this matter? Well, technically, yeah.
Yes. Of course.
And the goal now of this episode is to figure out what do we need to run and how can we reduce it to the minimum to get a sound benchmark result.
Okay.
Because that we just don't know yet.
Yeah, fair enough. But I guess when you go back to the code, there was this method that you showed, which was like run generators and update or something like that. Yeah.
Yes. So we run generators and update compilation.
Yeah. Is that so? That's doing 2 things at once, right?
Oh, we update the compilation. Well, I mean, in our case, we return the compilation, but for our benchmark, what really should matter is running the generator, nothing else. I mean, in a production environment, this must be done. Otherwise, if we don't update compilation, how do we get anything out of it?
Okay, fair enough.
But in our benchmark, we don't need it.
Haha.
So we just Actually, yeah, let's take a peek at implementation. Let's rabbit hole. Let's follow the rabbit hole. Because we kind of see it once a generator. Actually, I never looked at it, how source generation works under the hood. So we run the generator and then we get some state.
Yep.
Well, that's a lie. We looked at it just 5 minutes before we started the stream, but not before today. Maybe I'm lying too much. Maybe that's why Twitch blocked us. I can't get over it.
Maybe it's
I
like
can't get
all
over
all the promises that, oh my God. I mean, we said we're going to do benchmark like last year.
That's right.
I mean, it's August, so.
And to say too little, too late.
Too little, too late.
If it says exactly that in the email, I will accept it.
Yeah, I'll be like, fair enough.
Yeah, sure. So I would expect this one's now our generator, and also return some state. I guess the result of the generator. Actually, can we take a peek at this type? That's the generator driver state. Okay, so the generator driver also has a state which contains generators, incremental generators, some states, additional texts. Oh yeah, because in compilation you can also have additional texts. Those are, for example, non-C# files. You could have a JSON file as an additional text, because you could have a source generator that gets a JSON file as input and then generates C# code out of that, for example. We can have additional texts. Yeah, our parse options. Some options provider, a state table. Okay, stuff that I don't understand. Disabled outputs. Oh yeah, and the generator driver. I think you can also. Is this something that you state in the generator driver? Or am I mixing stuff up? Because there is a way to disable outputs. Incremental generators, they have multiple stages. And you can disable some of them. Is this then done with the generator driver options, I suppose? I'm just not following this rabbit hole because maybe there is some option that perhaps we need that. So let's take, wait, let's just have a constructor. Yeah, there's a constructor. Oh, there we go. It has these options. It has disabled outputs. Cool. And we can disable outputs. We could, okay, what are the outputs that we can disable? We can disable host-specific outputs, implementation outputs. We can disable the post init and the source output, or none at all, which I suppose is the default. Because maybe that's an option that we may want to consider. Yes, I know. Because in our generator, we have kind of multiple stages. There is multiple phases. There's the post initialization phase that is called super early and doesn't have any context. If we take a look at this, well, okay, there is still a context because there's always a context, but this context is very, very petite. If you take a look at it, this context has a cancellation token, so we can stop producing source code if we know that the host, the generator driver, in our case now we are the host because we are hosting the generator driver, has canceled creation of it. And we can also, and we can add sources. This is new. Add embedded attribute definition. In the last episode, we had Jason Bock and Stuart Lang were pointing out that now there's a new feature in Roslyn when you emit attributes.
Yeah.
Because, for example, this is actually a problem here. We emit this attribute as public.
Yeah.
What if I have, now this is in one project, and now I have another project that is also emitting this attribute, but now I make one project depend on the other. Now this attribute is emitted twice, and this may cause problems in the same namespace. Yeah. So this could then cause problems. And well, I guess the solution is to emit this internally and also apply this new attribute. There's this embedded attribute definition. And I think this is, oh no, this is just adding to the source. Yeah, this is adding a source for the attribute. And then I think embedded attribute definition. And I think then we should then in our generator then have global. I really don't know in what namespace this is. Wherever this new attribute is, dot embedded attribute, and also attribute this attribute with this embedded attribute. And then even though if we had it internal, because we could still have the problem if we have two projects consuming this generator, both internally creating this attribute, no problem. But what if one project is depending on the other project and the project is making the internals visible to the other project? If you do internals visible to, because you can make the internals visible to a specific project, it's essentially making it public for that project. And again, we again have the double definition problem. But then with this attribute, we don't have the problem anymore. Mm-hmm. But what if this attribute doesn't exist? And this is now what this new add embedded attribute definition is for. But this is quite new in Roslyn. This didn't exist in the previous versions, I think. So long story short, what we had for a long time is just a cancellation token and adding source. We see we can not inspect. There is now information about the user's compilation there because it's super early in the pipeline. Mm-hmm. There is no input. There is no user code to observe. So this is only code that we want to emit unconditionally, like an attribute that we always need. Mm-hmm. There's a post-initialization phase. And then comes the source generation phase, which, I don't know, that's not the official name, but I'm now calling it like that, where we actually have, in that context, we now have way more context. We have a syntax provider, so we can get syntactic information of the project, basically the source code of the user, and we can act on the source code of the user. We also see the compilation if we want to get some type information. We see the parse options. We can understand, hey, this project was parsed with C#11. Mm-hmm. Additional texts like the JSON scenario that I mentioned, and more stuff. And when we register output, in our case, when we actually want to write source code, because with incremental generators, you build up a pipeline. And in these pipeline steps, we mentioned there is some memorization going on. So if in this pipeline, because an incremental generator runs many times, if I do a .NET build, a generator runs exactly once. Mm-hmm. If I'm an IDE, the generator runs all the time, maybe with every key press, or every 5 seconds, or whatever the author of the tool, in this case writer, or when it's on Visual Studio, whatever Visual Studio authors do, how to invoke the generator. It could be on every key press. So this runs a lot. And when we have multiple steps, if the input to a step from the previous step is the same as with the last one, and source generators should be deterministic, then I don't need to run this step, but can reuse the previously emitted output. Mm-hmm. That's memorization. So we can basically short circuit our pipeline if we know at some stage, at any stage, hey, this was the same input to this stage that we received earlier, or to this step. I cached the result that I produced last time with this input. I assume we are deterministic, so I don't produce this output again, but just return this cached result and short circuit the pipeline. And in this case, like if somewhere along the way, the pipeline gets short circuited or memorization kicks in, then we don't call which is the source output again, and just the previous result will be reused, and we don't need to generate the string. So it's a massive performance optimization when it comes to incremental source generation. This is actually something that we may run in. Perhaps there is some memorization going on, and when we run the generator a lot of times, maybe it's only the first time that you do the work, and the second time, that's the same input, stop. But in our case, we would like to run the generator regardless, so we need to find out how to do that. But this is now another phase, the register output source. We can also register implementation source output. There was a difference between there's also register host output. I think this is also new. And I do not know what it is yet. Yeah, we see that's experimental. Mm-hmm. Okay, I'm going a bit on a tangent here because this is new and I don't know what it is. Register host output. This is just briefly.
Famous last words.
Just briefly. Okay. Yeah. Okay. No. Yeah. I keep it for a tab. That's for later. But that's also brand new. I don't know what this does yet. I will find out until next session. Perhaps this. Perhaps this will be our trivia for next session.
Yeah.
What does register host output do? This experimental feature of Roslyn currently. But there was previously with register. There were only those three: register post initialization output and register source and implementation source output. The difference was, well, the difference currently there is currently no effective difference because all of the tools .NET, well, the .NET SDK doesn't make a difference here, but Rider and Visual Studio, they treat them equivalently. The idea was that the host of the generator, like Visual Studio or Rider, would treat them differently, as they would run the register source output only when running a project, only for when the project is actually built and run. So when you need when you need something to run, or is it the other way around? I may mixing it up because it doesn't matter what you use because tools don't treat them differently. But the idea was that tools do treat them differently, where I'm not mixing it up, where one is only creating whatever you need in order to compile. Like maybe the generator creates a new method that I call in my source code. But the implementation of this method, maybe it only creates the method without implementation. So the method does nothing in order to generate this method faster. It's similar like I think that's similar to like reference assemblies and implementation assemblies. Where the implementation, I guess it's the other way around as I actually expect it to be, where the implementation really would have all of the source code that I need to run, but the other one only has the public surface area, the public API that I need to compile. Again, as a performance optimization. But this never came to effect because tools don't treat it differently. So it effectively doesn't really matter. Yet, since this, long story short, since this facility was created, we could ignore specific output. So this is something that we are now the host, since we are using the generator driver. This is what Rider and Visual Studio could do too. For example, ignore the implementation phase, or ignore everything that is registered with implementation. So if we were to register implementation source output, this would not be called, because we disabled this output. But I suppose in our case, we don't really want to suppress anything from the generator. We want the full generator to run. So I suppose we need the none option. And we can also enable a Boolean to track incremental generator steps. I think this is part of when you have a generator step, you can also additionally, I may mix it up, provide a step name. Let's find that where this is. Oh, that's a with, yeah. So we have, for example, here this where stage is basically a filter, and we could also say with tracking name, and we say this is the filter. Now this step gets this tracking name, and I think this is then part of when we run the generator and have our output here. Somehow we can take a look at the steps results. We can get the one result, and the one result has results. And let's, I don't know, get one of these results, and these results have tracked steps. And we could then, that's a dictionary, so we could get the tracked step of the filter that we got. And now we have this step here. But we are not using this in our benchmark. So we can say false here. Maybe we should even say false here, because what's the default? Okay, the default is false. Okay.
Oh.
So the default is don't disable anything and don't track the output. So I guess, okay, so we didn't do anything, because if versus is true, we would do more that we actually needed to do, and we only want to do the minimum. We do not want to do additional work, only do what is minimally required to run the generator to get reliable results. Yes, long story short, we can also pass options there. I think that's an array, so we would need to do, that's an array, so we would need to do something like this. No. Aren't they in the generator driver? No, they are not. Additional text, generator pass options. Oh, yes, they are, but there's way more options that we could set. Yeah, there is like nulls and nulls and nulls, something like that. Yeah, anyway, we use the default anyway, so it's good. Sorry, I was interrupting you.
No, that's fine. And just in case you hear noises, let me know. It gets too noisy. I live next to a stadium, and there's a football game on. The local team, so it usually gets very noisy.
A derby?
What?
Is that a derby when local teams are?
I don't know. Oh my goodness.
So there will be not necessarily fights, but there will be.
No. It's like they're very tame and calm, and it's usually like a family event, so there are loads of like kids and stuff. So everyone's on their best behavior. It's a nice one, a nice team. Yeah, but they're noisy. Cool. Okay, perfect.
How did we get there? I totally lost the trail of thought. To do as little as possible. Generator driver options. Oh yeah, we were looking at the implementation. Okay, so we just run the generators and then we took a look at all the states and such. But this is what the
okay, not, an hour into the stream. Good.
Today is not just a discard day, but also lose the trail of thought day.
Yeah.
Going on a tangent. Is that the correct name?
Tangent time.
Tangent time.
That's where the band is. Too many tangents.
Yeah, I guess
you already had enough tangents for this year, so please come back next year and try again.
Budget is used up. Insert coin. Okay. Maybe they want money.
Okay.
Oh. We run the generator.
Yeah.
With the different steps. We want to run all of the steps. And then, some diagnostics are extracted, like errors and warnings and infos. Then there's an array builder. We get the generator states. I think there is generator states because we could run multiple generators.
Mm-hmm.
And then of all of the states, we get the post init trees. So that's the source trees that get emitted by the post initialization phase. And we get the generator trees that I assume are then the other two, which is the output and which is the implementation output. And I suppose also which is the host, whatever this new thing is. Maybe this new thing is something that actually does that, what the difference of the previous two, the source output and the implementation source output meant to be, but never come into effect. But yeah, okay, for next stream. And then we create an output compilation. And this output compilation is then out returned. But we don't really need that. We actually kind of discard it. So yeah, what you were trying to get at is exactly, we just run the generator, which only does this part and this part, and we get rid of a lot of additional stuff. Very good.
Yeah. Let's try that.
Get rid of, so let's find the end word, and let's get rid of all of the ends.
Mm-hmm.
We don't need that, but then we don't have an output compilation and also no. In general, it is recommended that a benchmark returns something. So maybe in this case, we return the result of there because, yeah, once it generates and produces an updated generator driver containing the results. And I guess this is what this method is doing. It then extracts the generated trees from the result and returns them as a separate thing. But yeah, maybe we just return it. Can we change the type? Yes. Cool. So let's use only, I guess we can copy that to the others as well. Only do one generator, so we do a little bit less already. And maybe the result then is a bit better. We don't need that because we ensured that we run both phases, nothing is ignored, and we don't track the steps because we don't need that. And return. And here we actually do, well, that's the cleanup where we also do some checks. So here we actually do need it. Oh, cool.
Okay, cool.
And sweet. Now let's run the benchmarks, but since we're on stream, we'll also add the short job one, which makes the benchmarks not to run that long. Now the results are not as accurate as without that, but for the stream, we should still get a do the numbers add up kind of an output. The setup communication should not be implemented in an assembly containing reference. Yeah, we shouldn't use Visual Basic here. Okay, be gone. Because we enabled all of the analyzers and did warnings as errors in release mode, so we're quite strict here. Why actually? It's not always provided by C#. It's not always provided by C# compilation, so it's cause interesting. Oh, because it's a C# compiler extension, and then there is no Visual Basic. Okay, yeah. Because we said this is, where is it? Oh, in our generator. We said this is C#, but we still had the Visual Basic dependency. So we could use Visual Basic code, but if we were using Visual Basic code in a generator that was assumed to be C#, yeah, stuff may get not as we expect it to be. Cool. Now, while these run, can we find some other patterns that we could improve? Or a way of how to understand what's going on?
Well, maybe the thing you mentioned before with the iterator thing, right?
Excuse me?
Iterator.
Oh, the iteration.
Iteration. Yeah.
Perhaps let's give that a try. Maybe that. This could be the next try to have some iteration.
Can you actually
setup.
see me and hear me fairly well, or is it slightly breaking up?
Okay, no, good. So far it's good.
Okay, good. I can just see my IDE working a little bit slow, and sometimes the football game has to do with that. So let me know.
Cool. So we got some new output, and okay, let's see. Is this now? I guess they're still quite similar, right? Because we create the driver, create the compilation. Well, I guess nothing should have really changed there. But well, update the compilation seems to be fairly cheap. We don't really spot anything.
Driver and run is faster than just run.
Yes. Right? Wait. Yeah. Well, this could be some of the inaccuracy that we have, because we just do a short one, and we also do live streaming on this machine. So there's quite busy. So those results aren't. So if it's off by a little, no concern. If it's off by a lot and doesn't add up, then it's an indicator.
Okay.
But fair observation. But yeah, I guess that kind of shows that generating a driver in this case is just generating a driver is quite for free. Well, on the air quotes. I guess this also is confirmed by that. This seems to be not doing too much. I guess just creating the driver isn't doing anything, but I guess then when the driver is running a generator, then it will do stuff and allocate and cache and whatever. But before it does anything, it's just creating an instance. Well, create compilation, I can imagine this takes a bit because there is some parsing and stuff going on. Definitely the workhorse is running the generator. That's, what's it again? Nanoseconds, microseconds. So we have half a millisecond kind of a thing. But it still doesn't really add up, does it? Because, well, doing everything.
Yeah.
Okay, that's also kind of weird. Doing everything faster, because there is quite a difference between these two numbers than just doing the compilation and one. But again, yeah, this could be very much related also to streaming. Maybe let's also give it a try with the iteration setup.
Iteration, yeah.
Question is, how do we combine that? I don't want to do all too much commenting out and stuff, so I'll be duplicating this class with iteration. Yes, please.
Oh, and now we can delete, not comment, right?
And in the end, let's kill. Maybe let's delete all of the benchmarks other than the one that does everything. And from there, we will do something with the iteration. So let's do a iteration setup.
Yeah.
As well as an iteration cleanup. Now, yeah, what if we would do in the operation setup? Remember, with signature already declared. Oi.
And get rid of this driver and run as well, right? Or
yes. No, wait. No, we will keep that one. So, but this is now our one then. But we can get rid of the rest of the benchmarks.
Okay. I'm confused. I think I'm out of my code with me is out of sync a little bit. Oh yeah. Oh. Okay.
Okay.
Now I'm back. I think. No, I think I'm back. I see your highlight. Woohoo!
Hey. Internet is also slow today. Oh yeah. They're also against us.
But they cannot stop us.
Not all odds are against us.
Yeah.
Thanks for joining, you salty devil. So if we do, well, maybe we don't need a cleanup. If we do in an iteration setup, well, what we would set up and then do the run in here, I guess this should be as. The question is, what do we compare it with? How does this now validate that this is good numbers? Well, maybe let's give it a run. But I'm number one. But I would be quite uncertain of what is this result telling us. What could we compare it to the other results? Now, of course, I got rid of the other results. That's bad. Yes, please. Maybe let's open them side by side. So, well, we definitely shouldn't run two benchmarks next to each other. And let's do the previous one as well.
Okay.
So this one now runs just a run because, yeah, what this now is doing is this iteration setup is run many, many times. So is run with every benchmark. So we basically always get this loop of both of them. but the iteration setup is not part of the measurement, only the one is. I think there is some documentation that this is not recommended to do in every case. If we take a look at the documentation, did you see that? There was animation.
No, I didn't
There is
see
a bit
it.
of a fading going on. Not sure if it actually shows on screen. This is new. Or I haven't been on the benchmark.net documentation side for
Cool.
quite a while. But there is, I guess you notice the jump here of the source.
Yeah.
It just shows it and then it starts rendering it differently. There's a bit of a fade going on. I'm now that's similar like to the nuke rocket, right? Could do this all
Not
day
quite as cool as the nuke rocket.
If we go to feature, setup and clear down, iteration setup. Method marked with iteration setup will be executed exactly once before each benchmark invocation. It is not recommended to use this attribute in micro benchmarks because it can spoil the results. However, if you are writing a macro benchmark, a benchmark which takes at least 100 milliseconds, and you want to prepare some data before each invocation, iteration setup can be useful. Basically once, and then same with the cleanup. It is not recommended for micro benchmarks. Okay, so a micro benchmark is below 100 milliseconds. A macro benchmark is above 100 milliseconds.
So we're above, right? No, nanoseconds.
I would.
Milliseconds.
We're just 6 milliseconds with our generator. So this is quite not suggested.
Oh, but then what can we do? Like, what's the?
But yeah, let's see. Let's see.
Oh, we do it anyways because we're breaking rules.
Yeah, maybe.
Okay.
Yeah. So what does this tell us? Now this is
benchmark.net will ban us too.
With good reason, I suppose. So this benchmark is now telling us to run the generator with a new compilation and a new driver, but that driver not being part of the result. And that's 600 milliseconds, so that's 6,000 nanoseconds. No, 6,000 microseconds and 600,000 nanoseconds. Am I writing this wrong? Correctly? 650,000 nanoseconds. And I guess this kind of puts us like in here, somewhat-ish. Again, we do the short one, so we can't, but just from the scale of it. Because running, so there may be a bit of a difference, because running the generator with a reused compilation and driver, it takes 550,000 nanoseconds. But running it on a fresh one takes 650,000 nanoseconds. So that's 100,000 nanoseconds more, which is that a millisecond of difference? Not sure if my math is right here.
Quick maths.
Maybe quite off. I was wondering if we can force a result, because it kind of scales it. Oh, maybe let's remove these two, because then we get something that is easier comparable. Oh, come on. Maybe it should be quick driver, but is there a way to skip a benchmark? Like with tests, there's usually some skip attribute. I don't think there is. So let's comment them out, and also this one. And let's run this one again. So we should get the scaling then should be all in milliseconds, and we can easier compare them without me embarrassing myself in math. Well, a simple math. Dividing and multiplying by 1,000.
No, not today.
Not today.
Maybe next week.
I'm also wondering, should we have something like an empty generator? Would this would this give more of a result, or because this generator does some? Well, the generator does some stuff. Yes. Would it help analyzing with just an empty stimulator that does nothing?
But then
Did I run the wrong one?
know.
I did run the wrong one. Excuse me?
Yeah, I was wondering if it would give any value. Because
So
we would then definitely not have these, when you mentioned that if there's no change, then it just doesn't run. So if there's never a change, or if there's never anything inside, so we would probably get, oh, well, it doesn't run or runs empty is probably still different. So maybe that might simplify things.
Should it be as empty as such? Wow, this is like super empty. Well, I guess this is super empty. But what about one that kind of that is only somewhat empty, which does something but yet nothing, like registering? Because maybe if it doesn't register anything, now is this giving? Are there again some short circuits going on? If we have some post-initialization output, but quite don't do anything with it, and we also register a source output, which, okay, this one needs some context, so let's feed in context syntax provider. No, the syntax provider, we can't use the syntax provider, but the options provider. This does not work because this also takes a cancellation token, I suppose. Yeah. So we registered some stuff, but still quite empty. Maybe for the fun of it, let's also register an implementation output. And also the new host output. I'm obsessed with this host output.
Why not?
Oh, this has a different signature. I'll get rid of it. So, okay, let's see what the results now say. We have, okay, so this is now microseconds, and we have milliseconds here. It's, I guess, a bit more comparable. So if we just run, we have, can we put them side by side? No, we can't.
Okay.
I'm now wondering something. Maybe the situation setup is indeed quite spoiling the result because we are below. Because this kind of doesn't really add up, does it? Because if running everything takes 1 millisecond, how can be running the generator with new drivers be 7 milliseconds? So it's either this, that we stream, that we do the short one, or that this is not a micro benchmark but a macro benchmark. Vice versa. It's not a macro benchmark but a micro benchmark, and indeed spoiling the result, or a combination of all of them.
Yeah.
We actually get a warning here. The minimum observed iteration time, which is very small. It's recommended to increase it to at least 100 milliseconds using more operations. Well, we could make our generator more busy.
Okay.
Maybe we call this
from super empty to super busy.
This would be the busy generator. And it kinda does one thing, and one thing only. It getting rid of everything, which is a source output with, okay, maybe not everything. Maybe let's do a syntax provider, because, well, if this is empty, nothing will run, right? But we need something for that pipeline. So we could say context dot, let's use the, well, we don't have additional text in our example, so this wouldn't work. Yeah, we need a syntax provider. We create a syntax provider. We take a peek at what the syntax provider takes and just quickly draft something that does something. Oops. And we need, as a first argument, a func that takes a syntax node and a cancellation token and returns a true Boolean. And as a second method function, it takes a context and a cancellation token, and it returns also something. Empty string. And this will be our syntax provider. And yeah, because this is now, I guess, just strings, but it's not. Haha, there we go. And we then just wait. Fred, not doing something very bad. Fred.sleep. So let's wait. A second is maybe too long. If we wait 10, well, what we're not doing now is we wait 10 milliseconds, basically for every syntax node that we find.
Wow.
Because this is iterating every syntax node.
Okay.
And I guess in our example, how many syntax nodes do we have? We have like, that's the setup. We have like 100, 200 syntax nodes. So we would wait 2 seconds.
Well, okay. We can do 2 seconds.
I guess what I'm trying to get at, this really should show up. What if we do 20 seconds?
Okay, now you're pushing it. We're on a live stream here.
It's quite enough. Yes.
No, I mean, I'm just kidding. We can do however long you like. We can also just let it running and have a, I don't know, joke round in between.
Let's give it a try.
Or just a tangent into this the tab that we have open.
Let's run this now. Let's run the benchmarks with this busy generator.
Yeah.
And see what this one does. Okay, maybe we should run one benchmark at a time. And if this gives any result, what would we expect? Kind of that it takes 2 seconds, something-ish, if it was indeed 200 syntax trees there. But it's running way faster. So perhaps we actually do have some memorization going on here. Because, oh, wait a second, we get a lot of warnings. Oh. Yeah, because in the cleanup, we still have basically we have an assert, we test something. Oh, wait a minute, but what do we test? We test if the compilation has no errors, but we have an error. What's the problem? Do we see the problem? There are not any results. Exception during compilation had errors. That's bad. Can we get the error? Errors. Let's change this link to just the errors and say if we have any errors, then please create a string that selects no, is that an aggregate actually? If we do an aggregate, I haven't done an aggregate in a while. is that the initial one? Then we have a current and diagnostic, and we always add up the current string plus, I don't know, like a semicolon plus the message of the diagnostic.
Okay.
And then should get some information about what our error here is.
What's an aggregate, or what does that do?
It is. Is there another word for that? I suppose there's another word, but it runs over all of the elements of this enumerable and gives the output of the previous current to the next one, starting with this initialization here. How is this one called? The seed. So we start with an empty string. Then the first iteration gets this empty string as a current and, well, the current element. And it returns another string, which is then the input for the next diagnostic. And for each diagnostic, we now get a result that the previous one has aggregated over. So if we were to write an aggregate where we start at 0,
Yep.
and then every time we say current plus 1, and the result is now an integer, the result would be the same as if we were saying errors.count.
Ah, okay.
Because for each element that we have, we iterate the previous number by, we increment the previous number by 1, starting with 0, which is basically what count does, but in a more verbose fashion.
Okay, cool.
And
So
let's see
what the error
is.
Okay.
Why does this not? Did I not save?
No.
I didn't save apparently.
In one of our previous episodes, it was hilarious. We were debugging for quite a while, and then we just realized we forgot to save. Yep.
I should enable autosave. Still haven't done it. Or have I disabled it again? Because at one point, or was it when we were on Visual Studio time? It's somebody yet, because we had this, and then I enabled it. Let's find it later.
Yeah.
So what's the problem? There we go. The Typonesis couldn't be found. Yeah, because of course. Because our generator doesn't emit this attribute anymore. Be gone. Of course not. Now this should work. Good thing we actually have a bit of a assert here, because this would have gone unnoticed and we would have made wrong follow-up assumptions. So perhaps even, perhaps this should be a part of our generator tool of our library as well, to allow, well, maybe not as a library, as a proper testing library, but allow some kind of a smoke test, some of a brief soundness. Did stuff actually run?
Yeah.
Did I provide input that actually makes the generator run, or does it make it go boom? So yeah, that's actually not a question mark anymore. We definitely want to have some some testing facility there as well. And okay, cool. So this is microseconds. I would expect this to be way more. Okay, let's go to the busy generator and make it go crazy. Let it make the feeling that I have.
Wait, let me just sum up, because I feel like my brain is starting to get fried. So we expected it to be much larger because we had this thread.sleep, right?
Yeah.
And that we were sort of like roughly estimating that it takes 2 seconds, but we're not even in. Yeah. Okay. Got it.
But far from it. So now we wait 1 second per node found, and we definitely have more than one node. So there should be at least 1 second.
Can we see how many nodes? Can we like, is there like a node counter?
Ooh, no, but we could
Well, we'll see how many seconds. So
build a generator that emits that for us, and then we assert it. Yes, we can.
Sounds good.
Ooh, maybe this is actually showing. So, okay, now we see, oh, this takes a while, right? This takes a lot.
Yep.
This takes maybe, that's too much. For every syntax node, yeah, that's definitely too much. Went crazy here.
What?
Let's do 100.
Why?
To shorten the time by.
We didn't even.
Yeah, what if it's really 200 nodes? Then this would have waited 200 seconds.
Okay.
I mean, we would finally have an excuse where we always go over time.
As if we need an excuse. Like it's already like I think everyone would be shocked. I think YouTube would ban us if we didn't go over time.
Finished on time. Justification.
Yeah.
So what does this? Because there's also some stats put out now. We really need an author of the tool, or I need to complete reading the pro.net benchmarking book finally. So this is like second preparation. But it seems that it's always kind of workload result. It always like the second. Okay, so it kind of looks like it does what we expect it to do, to run a long time, but continuously. So maybe because that's, what's that, 500, no, is that a comma? 500 nanoseconds per operation. 500 nanoseconds, but we were at least 100 milliseconds. Something, I don't know, something doesn't add up.
Something's a bit weird. So basically what you're saying is that we don't hit this thread.sleep, or do you think it's getting...
No, nothing got run. I'm not sure what completion. Why does it say completion errors again? This is not. Oh wait, which benchmark did I run? Did I run the other one? Such a fool. Because we have two different.
What fools these mortals are. That's my Shakespeare quote of the day. And you actually should know this because we've seen the play, haven't we?
That's part of the Tempest. Oh no, not the Tempest. The
Midsummer Night's Dream. Well,
yes.
You can be very glad that I didn't drag you to the Tempest, because I'm a Shakespeare lover, and that that play even took it, like, I don't know. I found it very tough to get through. It was, when I watched it last, there were some really famous actors in it, so that kind of made it worth it. But other than that, it was a little bit boring. A little bit boring.
Well, maybe next time, next level. Does this play? Yeah, perhaps.
No, it doesn't. Perhaps nobody in this country ever
does it play. Okay.
Plays it. For good reason.
Well, I see.
No, it's not. It's not that bad. I'll keep an eye out, but I don't think it's gonna happen. Maybe NDC London, and then we can see it there.
Yeah, you have to submit again. Okay, cool. So I now applied the changes that we didn't want. Okay, that's now showcasing the problems of copy pasting. Now running the code again and assuming that it will pass, but taking a long time. So we hope. And what's the average? Okay, the average is now yeah, we actually saw this already in the stats, kind of 1.7 seconds. What does this mean? If we wait, well, or roughly, I guess we can never be too sure, too exactly, as timing is threads to sleep and stuff. It's perhaps not the best timing, but what kind of we would assume if we have 1.7 seconds, and if we were waiting 100 milliseconds, we should have what's that? Should we have then 17 syntax nodes? Is my math right? I'm also mixing up no, that's definitely the comma. So should be right.
Yeah.
So we have 17 nodes, and let's confirm that by having our busy generator, instead of waiting 10 seconds, actually create an output. So we run this code, we return, I don't know, an empty string per node, and then we collect. Because currently we get one result per node that we find, and now we're collecting these results into a single array. So we now no longer have a string source, because so what happened previously was for every node that we find, we create a result, and for every result now of this pipeline, which is an empty string, this method gets invoked. So if we have 17 nodes, this method is called 17 times. If we are collecting these, now those are no longer 17 nodes, but a singular node. So this is no longer a string, but this is now an immutable array. Immutable array of string. And we can just count that or get the length of it. And we could print this to some source code. So we can say context, add source. We call it count.g.cs. And what again do we need to pass? Just a string is good. So the string that we pass will be the text. Do some nice string interpolation. And Wider isn't happy with tabs. It does spaces here.
Ha! That's funny. After lengthy discussion that we've had, choice isn't up to us. Oh, it is in this case. Okay.
Yeah, I need to force it though. Maybe let's do a comment of interpolated string where we say nodes the length, and we put this text out. And we should be able to assert that by checking in our benchmark. There's the syntax trees. I think there should be also, aren't there like generated trees? Oh, we have a issue. We run in this already. So here's the output compilation. The output compilation, I think, that contains everything. What we can do is getting a result driver. Well, I think they call it the updated driver, right? So we can get the updated driver, and the updated driver now should have a result. And we have multiple run results, and I think this is per generator, so we should have a singular one, and we can get there generated sources, which again, we only expect a singular one, which should have a text. What is that type? That's a source text. Maybe I split this up into separate lines so that if it crashes, we know where it crashed. So that's the result. We get the source. And we get the text. oh, sorry, source.toString, I suppose. And this one should be, in our case, comment 7, node 7. Oh, it suggested node 17. This is what it should be. And then we can throw an invalid operation exception. Actually, if it's not, then we can say output unexpected with a bit of a typo, and we put that string out. Unexpected. There we go. Where's my syntax error? Semicolon, not full stop.
Yeah.
But let's for now throw this exception regardless, so we actually see the text. So we should now get node 17. Converting null literals.
What?
Problem. Is this in the generator? I suppose that's in the generator, because we have a bunch of warnings. Let's get rid of all of the code that we do not need. And with a bunch of warnings. Where is our nullable warning? Let's just do exclamation mark here. Is that suppressing it? Comment null literal in, oh no, it's actually in here, in line 90. Ah, this toString here, exclamation mark, cool. And unreachable code detected. Ooh, that's okay. Yes, that's unreachable. So what would we expect? We would expect this to fail and say node 17.
17, yeah.
Then this would add up.
Drum roll.
Output expect Microsoft generated. Oh, okay. This toString. That toString is off of object and giving us the type.
Oh no.
So we need to do.
Okay.
I don't know. How can we toStringify this? Oh, there is a source text. Oh. And I suppose this is what we toStringify. Is there a full? No, just a toString. And that now also doesn't have a nullable warning because that's not off of object, but actually off of source text. That's overridden. So everything, yeah, that now looks more promising.
Can you hear the game?
No.
No. Okay, good.
No, yes, no, I could. A little bit.
They're singing.
But I also realized we shouldn't. We're doing unit testing with benchmarking. We should write a
We
unit
are.
Yeah.
Whoops.
Anyway, node 16.
Breaking all the rules today.
16 nodes.
That's
so
pretty
that
good.
Kind of adds up. That's a good sign.
That's a very good sign.
Wondering if we apply that same logic to the other generator where we do more stuff. And because here we are also using the busy generator. But let's get rid of the benchmarks that don't run the code. So here we run the driver, here we want to run the driver, here we want the driver, here we want the driver. And what am I expecting now? Maybe let's bring back the timer. Thread.sleep. So there's actually 16 nodes.
Mm-hmm.
But let's sleep more. 2 seconds.
Going all in.
And but this should only happen once. And let's find out. So in this benchmark with the iterations, well, this now should be roughly 2 seconds. And then we run the others, which now should or should not be. Then we would see if there is some memorization going on, perhaps. If they are not all roughly 2 seconds. And this one,
Oh,
I should have removed the exception, right? So actually, doing it, expect it to be. Well, let's remove that.
if it's not. Oh,
We confirmed that is. Yeah, we'll convert it to a unit test actually. Currently, we are testing via benchmarks. I guess you can do that.
yeah.
And this will, because this would also be faster, wouldn't it? Let's see. Okay,
Yeah,
so
maybe a
it
little
says 2 seconds, it says 2 seconds, it says 2 seconds. So
Yeah.
that kind of looks like, so if with the iteration setup is correct, so it seems, but not suitable for micro benchmarking. So that's kind of an issue. Can we simulate similar
yeah.
result for the other part? Now let's run
Yeah.
the benchmarks that we had previously as well. Unless we have another mistake hidden somewhere. They use the same. Should be good. And we're not using any code that's not generated. So it should also be roughly 2 seconds. 2 seconds, 2 seconds. Yeah, that kind of looks good. Also looks good. Now we come, okay, we have 2 more left. 2 seconds, 2 seconds. That one also looks good. But this one as well. Why does it now? Why do now all the benchmark where we previously kind of weren't sure if this adds up and something was fishy or something that we couldn't point our fingers on yet? Now looks, because they now all take. So it seems that, do you know what I mean? Does this make sense? So,
I mean, it's, yeah, this can add up, right?
Because now it adds up, but previously it didn't. What's the difference?
No, but does it? No, because if run on its own takes 2 seconds.
Yeah.
And compilation takes 2 seconds, then together they should be 4 seconds.
Oh, no. Because, no. All of them do the run, and it's the run part that takes 2 seconds. But creating the driver and creating the compilation, that's like 100 nanoseconds and 400 nanoseconds. So we won't be able to really see this in this benchmark. Especially now with short run and streaming and such. So this will be quite, in the seconds area, this will be indistinguishable.
Okay. That's good.
There isn't
That's
really,
good.
So that means there isn't really any memorization going on.
So we didn't have a problem in the first place.
There will be a bit of a disappointing outcome for this
anticlimactic.
Other than Twitch getting us banned.
Yeah, I was gonna say, like, at least the Twitch streamers didn't miss anything.
What does this tell us? Because we exited last stream with thinking that just in a setup, creating everything we need, the driver, The generator,
Yep.
the generator, the driver, the syntax trees to create the compilation, to sum it up, the two inputs, the driver and the compilation in the setup, and then just run, where is it? Just run the generator in the benchmark was kind of insufficient. Yeah, that was not audible. I hope you were cheering for our benchmarks.
Yeah.
Was in that didn't really add up.
Yeah.
But now we kind of come to the solution that it does add up. So did we make a mistake now, or did we make a mistake last time? So I guess now we have to still the same question. Is this the way to benchmark generators and get stable results? Or is it not?
I mean, it looks good. Like, we stripped everything. We've made it very, very simple. We got the expected outcome. But yeah, we haven't really figured out why the numbers were so different last time, because they were worlds apart. So we haven't really, I guess we're doing something right, but I guess we must have done something wrong as well when we originally approached it, right? Do you know what I mean?
Yeah. Now I'm wondering if can we control C back to what we had earlier? If we go using, what was that? Damn it. Shouldn't have erased everything. Let's see. I don't think there is enough Control C context window to get all the way back. No, there isn't.
No.
And of course, I didn't push or commit. So is the what were the numbers earlier? Because the feeling that we had is is that, I mean, generating a driver and the compilation is quite neglectable because that's like in the nanoseconds area. But then there was a noticeable difference between all of these. There was like 100,000 nanoseconds off.
Yeah, but also
where did this come
I am just thinking, because we did actually, like, right now we have compilation and run, driver and run, and all three. But before we had driver, create, compilation, create. No, they all did run before as well. We just renamed it, right? Did we change anything there?
Not really, no. Well, so what we have changed is that we only run the generator and don't update the compilation.
That was what I said at the beginning of the stream. Haha. Well.
Now I'm wondering.
Yeah.
I'll try one thing. What if we were to reuse the driver, because it returns some updated driver. And this doesn't work. Why? Because that creates the generic generator driver, not the specific C# compiler. So we need to go here. And also, I'll get rid of these ones.
If it gets too noisy, I'll close the window. Just let me know.
Yeah.
I think they'll calm down in a second. It just started, so.
Oh, it's party time.
Yeah.
If this does make, if we reuse the generator driver, does this make, or actually, because now I'm thinking, how do we actually get this? What does an incremental generator make it incremental? I want to reproduce. Because like I was assuming that we get some incrementality already, but perhaps we didn't actually. Perhaps we just didn't. We made some wrong assumption. But how can we, now let's prove the opposite. How can we get this incrementally working and then not taking 2 milliseconds because it's 2 seconds because it's not called again? Incremental. Because if we do one generators and update compilation, we could get the private compilation. Compilation 2, there we go. And we out compilation 2, but we discard the results. And this doesn't work because it's also just a compilation. And we would now be incremental, but also incremental reuse driver, kind of all of the permutations. What would this now yield? So I'm now expecting that this kind of is, oh, wait a second. If compilation, we initially need to set compilation 2 to compilation 1, otherwise this quite will not work. Ist gleich compilation. Where is it? There it is. So we basically, we give in a compilation with an output compilation, and then we use this output compilation. And if this is the incrementality of the generator? I'm now wondering. And let's see what this test yields. And then perhaps we can make this test. Well, this is not really a benchmark. 0. What would we expect? This should be, this should be like 2 seconds, what we saw earlier.
Yeah.
When we reuse the driver, will this have an impact? What do you think?
Yeah. I think yes. Don't you?
I kind of think no, but
Why?
Don't know. Let's find out. Then we have where we actually, oh, I made a mistake. Compilation 2.
Ha.
There we go. Yes. Where with the incremental portion, well, we now really use the reuse the compilation. But this compilation already has, wait a minute, this compilation already has the tree in it. Actually, I think these will be quite nonsense. And I think you're right.
Ha!
So this one
Nice.
should be the
we'll see.
Incremental portion. Because why would I feed in a compilation that includes generated results? I think these are bogus.
Okay, we'll see.
And we're using, I could imagine, because this one updates the driver. And what we saw earlier, when we take a look at the driver has information like, oh, that wasn't the other one, right? The driver has information like the run results. And the run results, they have information like tracked steps. And these tracked steps have information like, okay, key value. And the value, it's again a collection, have information like the elapsed time of each step. So we could technically, maybe this task is escalating to absurdity and we are not building a plugin for benchmark.net because I'm not sure if we can. Or maybe there is some sort of how extending it that we could. Maybe we're providing our own benchmarking tool. It's not a good idea, but it's not a good idea at all. But which also lists the elapsed time of each of the tracked steps so that you get like super detailed result of the inner workings of your generator.
Okay, but how much value does how do you, is that, wouldn't you just write smaller benchmarks if that's interesting? No, because each step you couldn't probably, I don't know. The thing is, my initial the thing is, Stefan, right?
Yeah.
Initially, when you started on this, I was like, it doesn't matter what you say, I'm gonna say no, absolutely not. This is silly, and absolutely not. And then I was like, but maybe it could be really good. And then you can see, and then you see where the time sort of went. But no, I think. Do we need that? Okay, do we want that?
Yes.
Let's
Do we
do
need
it.
it?
Probably not.
Well, because actually, if the thought that you have is a very fair point. This is a problem that I have in general, and I just realized recently that I never finish anything because it's always, oh, this a little thing of there and a little thing there, and then it's escalated. I'm like a feature creep. I'm my own feature creeper. And yeah, maybe that's version 2.
Yeah. Oh god, for sure.
So maybe we shouldn't. So I guess the default, the takeaway is that we may not should tie ourselves too much into benchmark.net. Yes, our tool, well, what we built can be used with benchmark.net, but doesn't have to. So that we then have some extensibility later to extend it and then provide like our own timings with Alex time and such.
Yeah.
How does this sound?
Sounds great.
Cool. And well, this could then even be its own UI tool. Well, I'm now kind of getting, if you drag and drop in your generator, you run it, you write some code like in what's it called? SharpLab or lab.razor.fyi, and then you run it, and then you get all the timings. Okay. We have promised way too much. That's the next 3 years of work. Anyway,
Yeah.
what we're trying to get at is not just the elapsed time that now put me on a tangent, but there's inputs and outputs. And
name. Yeah.
Again, and name, because it's a tracked step. And only if we track the step, we get the information. And with this input, because I think the name that we saw here would be in the generator, if we say here with tracking name, then this is the name that we would get, I think. We should have written tests and we could confirm. But then the input has an input index and a source. And the source, okay, I guess this is now getting recursive. So what about the outputs? What if we take the single output? Assuming there's one, there is a value of that output, but also a reason. And what is the reason? The reason can be cached, modified, new, removed, or unchanged. And I think this is where the incrementality is coming in. Like new, okay, this wasn't there with the previous one, or it's the first one. The first one, everything is new. If something is unchanged, well, that means it hasn't changed from the previous output. And something in cached could mean that if the previous input was unchanged, well, we can use the cached result.
Yeah.
Or something like that, or modified, or something was removed. But I think this is then where the incrementality comes in. Long story short, I'm trying to get it, or what I'm now beginning to understand, this information is not on the compilation. I was wrong there. This information is on the driver. So not only did I fix a wrong assumption of myself, but I also have 7 more project ideas and 10 more years of streaming. We can never die. That's the problem. Way too much work. And now, does this add up? And I guess it does, yeah. So we have I guess the incremental ones, they were just bogus. But the 1, yeah, those are so microseconds,
Mm-hmm.
milliseconds,
Mm-hmm.
millisecond. So microseconds, milliseconds, seconds. Yeah, so that's 2 seconds.
Mm-hmm.
But the incremental portion is microseconds. Because I guess it only runs a single time. If we would look at the output, I guess we would see. Would we see something? That's not the one. That's not the one. But this is the one. I guess we would see one long one. Or would we even see one long one? No, they're all short.
Mm.
We only see microseconds, milliseconds. There is no seconds, but the other ones, they all have seconds. So
Yep.
I think this kind of okay. Now we know. Now we build our own incremental generator driver host, just in case. Okay, so this is what we must not do. We must not reuse the generator driver, otherwise we get incrementality, and that would potentially then, I mean, incrementality is good, but not for the benchmark. We would always get super low outputs, but because incrementality kicked in and not everything of the generator was run again, like until completion. But the rest was. So I suppose just doing the run as we had after the first stream, but I still don't understand why there were difference in the numbers.
Well,
But
I guess we'll
maybe
never know because we got rid of it, right? We could watch the stream and then see.
yes, yeah.
And
Definitely.
if you would like to watch any of our previous episodes, head to our YouTube channel and check them out.
Do we still have? Yes, I'm posting the link in the chat, but only in the YouTube chat today, not in the
No,
Twitch chat, unfortunately.
just for our VIPs.
Yes.
Awesome. But well, I guess we still learned a lot about the inner workings. I think last time we were like, I don't know, we were more like setting everything up and getting started and sort of like, wrapping our brain around everything. Nodes and trees and all of that again.
That's fair. We also learned that for our what is it? Our generator, our deconstruction generator. Well, that's kind of a real life generator, but it was, what was that, 6 milliseconds? That was too fast for micro benchmark. So we can't really use the iteration setup. This could, as per documentation, could falsify results. So perhaps we now know that what we had earlier initially, when in the setup. So I guess we then have three methods to provide. We provide some sort of setup method where we can easily set up all the parts that we need. So the compilation, the driver, all of that stuff. Maybe we can strip some things away to reduce it to a minimum. And then we have a method that just runs. And we could also offer some kind of, for cleanup, some kind of assert where at the end we then check the output and is it really, where we could do some, hey, does this text exist kind of a thing? Do we have the same, so some limited testing functionality to allow some, maybe, hey, is there no error? And is there 7 output texts because we expected 7 output documents, and do they contain some string kind of thing? Yeah.
Not to encourage too much testing on this side, but just to give you a little sanity check or that sort of thing. Because they helped us.
They helped, yes, indeed. And we caught an error that would have gone unnoticed because we would have gotten numbers that wouldn't represent what we expect them to represent. And I guess we don't want to replace the real Roslyn testing framework or testing library, but maybe we can be some complementary. And as a bit of an have some testing, and if somebody would like to do more forward testing, then of course use the testing framework. Yeah, I suppose we have a plan, and then also a 2 years follow-up plan to build the elapsed time thing.
Yeah, I'm not worried. I'd love to like have an episode, maybe like like a Christmas episode where we look at like our oldest issue that we opened in GitHub and just see how old it is and what it was. Like, what was the first time we had this? Oh my god, we could do this. Let's just write this down.
Oh yes,
Would be quite interesting. Awesome. Well, that leaves us just with one question. When will we be back?
Yes, we'll be back in less than a week. Well, actually,
yeah.
Maybe to start with what we should have started in the beginning. Sorry for being 1 day late. We discarded our earlier plan and we removed it by 1 day. Which now, since we're gonna be back next week, we actually now only have 6 days in between. So we're back in 6 days on Wednesday, and we'll see how far we can get with a bit of something that takes shape into a NuGet package.
Yes, exactly. That would be really cool. But if you're interested in learning in between, or is it in between? Yes, it is. Stefan has a little something for you, a little knowledge share.
Yes.
A little presentation on Tuesday, right?
Yes.
Where's the date?
This is a new website. Our chairman,
12th.
just built a new website. It's amazing. And yeah, actually, Andreas and I will be speaking a bit of our testing and performance. Andreas will talk about Aspire. And I'll be talking about, well, of course, something with generators, because interceptors are very bound to be source generators, and how they can be used to get more performance and enable native AOT scenarios and whatever that all means. And do we also link to the event? I guess this is still missing, but we can go to the, I think, yeah, on Meetup we have the events of, well, in-person session, which is in Vienna, if you are close, or, well, remote, where we will be also streaming to Twitch, because this account is not banned, and YouTube, of course. And I will post this link into the YouTube chat only.
Awesome.
So, and get some very weird advertisement. Let's close it.
Yeah.
Oh, and here is my good night task.
Until next time, yeah.
Eric is pushing this session very much, adding 24 hours to my calendar for the next one. Don't go. Sounds too early.
So,
wonderful.
No. Yes, it's actually, so yeah, sun has already set on my end, but thank you guys so much for joining us, and thanks, Eric. It's always such a pleasure to have you. Yeah, and so yeah, we'd love to see you either at the meetup or obviously next time when we'll continue. And yeah, until then, thank you, and
we'll be back.